all here speak English, so we're gonna do it in English. So it's been like almost 2 years, isn't it? Almost 2 years, like 1 year and 10 months since we started to experience how to code and like what's AI, etc. And then now it's kind of it's been my pleasure to discuss a lot of things with Deshaun, one of the smartest kid that I have known. Am I in the right way? So he's gonna present the last 2 years. So let's welcome Sean Kim.
Hello and welcome everybody. Today I'll be introducing you to the world of coding and how far I managed to get on my journey. So this presentation will mainly have 2 parts. The first will be about coding and some of the general aspects of coding, and the second part will be about AI and a smaller subset of coding called machine learning. Part 1. So first of all, what is coding? So coding is something that can connect humans and machines. With it, you can program software that can accomplish almost anything. Examples of them in our daily life are websites, apps, programs, and games. Chances are anything technological that you can see around you likely had coding involved in creating it. Without the coding, your phone would just be a hunk of aluminum and plastic, and your computer would just be a chunk of metal with a glass screen. That being said, computers can actually really understand 2 things, on or off. And this unique combination of ons and offs is what allows the computer to know what to accomplish. This can also be represented in binary code with a unique combination of 1s and 0s. This information can be grouped into bits and bytes. 1 bit contains the information of on or off, and 1 byte contains the information of 8 bits. This grouping of bytes increases in multiples of 2, such as 128, 256, and so on. Although on or off may be a very simple and elementary thing to know, if there are millions or even billions of these sequences, then a computer will be able to know a lot and carry out a bunch of things. Programming languages are essentially translators. They help transform this confusing series of 1s and 0s into a format that, while it's not exactly like English or another language, it's much more easier for us humans to know and understand. So here are some examples of different programming languages. Examples are C++, Java, JavaScript, and so on. Each of these languages are different and unique in their own way. They all have their own strengths and weaknesses, and they are all specialized for a different task. And however, I learned the Python language. So Python is a language that focuses on high readability. This means that its syntax is very easy for people to understand, even if they have no prior knowledge on the language. And it's also multi-purpose, which means that it can be used in a variety of different areas and in a lot of different situations. It also has a command line, which is shown in the image here, which is a way that it can take in information and output them. So one of the most basic lines of code in the Python language is print hello world. This is often one of the most first exercises that a beginner in any programming languages takes on. When this program is run, it returns the simple message, "Hello world." This is an example of the format that Python uses. It's relatively simple, easy, and it's very easy to guess the purpose of it. I worked on some projects to help learn and practice the skills that I learned. So some of them were guess the number, hangman, and a student grading project. So my first project was guess the number. My goal was to create a game where you try to guess a randomly generated number, and using hints that can help the user find out the number and slowly get closer to it. So it was a very short and simple program where I first had to learn how to first generate a random number and go through a series of logical events that determined whether or not the user's guess was either higher or lower than the target number. And then it would tell the user it, allowing the user to slowly get closer to the actual number. So my second project was hangman. So my goal was to just recreate the traditional hangman game, where you have to try to find the letters and fill up all the blank spaces on a unknown word. First, I had to learn how to import a database filled with all sorts of words. So my program will be able to randomly choose one and display it. I used if-then statements to figure out whether the guess of the letter that the user guessed was in the determined word or not. And I also had to implement a penalty system where if the user did not manage to get the correct letter, then it would slowly go and fill out the letters in the word hangman until we lose. So nowadays, student grades can also be accessed online. In this project, I try to create a program that can do similar things. The goal was to use the data, which was the names of students and grades in particular subjects, and find out more information about the data set. So I received a database filled with names of students and grades in particular subjects. Then I had to manipulate that data and use different functions so I can figure out more information about the data set. For example, I created different functions that can either sort all of the grades of the students so that the highest ranker will be first, then second, and so on. I could also assign letter grades to each of the students, since only the percent grades were shown at first. I can also find out individual people, for example, the highest score in a particular subject, such as math. So some of the topics I learned about were the basics of coding in Python, variables, data types, such as lists, tuples, and dictionaries, loops and conditions, functions, and using projects to practice what we learn. Part 2 is all about AI and machine learning. So what is AI, or artificial intelligence? We can break this word up into two different sections. Artificial, meaning that to make machines appear to be intelligent, and intelligence as in the capability to organize and make decisions based upon data. Human beings are intelligent because they can use their senses to take in information around in the world around us and use their brains to act upon that information. So in machine learning, you try to create programs that detect patterns in data. So first, we have to train our model that we create with data. And labels are there to help us create more classifications to help us find the patterns easier. then our model will learn the patterns in the training data using various algorithms. And then we also have a separate test data that we use to validate the model that we created to see whether or not there are any specific flaws inside in our model and find out areas that we can improve. So some types of machine learning are classification, regression, and clustering. Classification is where you deal with data that have categories such as comparing the appearances of cats and dogs. Regression deals with data that only has one category, such as examining what makes one brand of cereal more expensive than another. Some commonplace examples of AI are Alexa, Google Home, Siri, smart assistants, advertisement that use information collected about yourself to target advertisement that you might enjoy, music and media recommendation, so that sites like Netflix or YouTube would recommend videos that they think you'll enjoy more, and video games where the computer has to act like a human being and engage in the user. So some of the projects that I learned and practiced in the AI is the house value project and handwritten number recognition. So my first project was a house value project, and the goal was to predict unknown house values based on its information. Examples of this information included number of bedrooms, the location, and of course the house value itself. The whole data set that we got was 20,640 samples in total. And from that, I split it up into two sections, the training data and the test data. So in the training data, it contains 16,512 samples, and we used 10 features, including how many rooms there were, how many bedrooms there were, and its location. And in the test data, we isolated 4,120 samples that we could use to test our model that we constructed later on. So I used a method called random forest regressor to create our model and find the patterns. So for our results, I used a variety of different algorithms, and they each produced a different error rate. As you can see, the decision tree regressor performed the worst with an average error of just over $70,000. And later on, I took the random forest regressor and made a couple of tweaks to it and tuned it so that it would perform the best. And we ended up with an average error of just about $48,000.
Can you elaborate more? What's the error indicate? What do you mean by error?
So the error signifies that it's the error in like the house value it predicted. So the model that we created took in information of a house that we did not know the value to, and using only the information such as the number of rooms it had or how close it was to the ocean, it made a guess onto how much it thought the house would cost. And the difference in the predicted price and the actual price is the average error, which are these numbers. So my second project was the handwritten number recognition. The goal was to identify handwritten numbers contained inside an image correctly. And these are just some of the examples of the images of handwritten numbers. Inside the whole data set, there were 70,000 images containing handwritten numbers. from here, we took 60,000 images and put it in the training data. Each individual image was 20 by 28 pixels, which made for 784 total features. Since each pixel contained the information of on or off, which counts as a feature. And for the test data, we isolated 10,000 images that we can use later on. So some of the methods that we use are SGD classifier, random forest, and K nearest neighborhood, or KNN, all of which are algorithms that we can use to help us identify the number better. So for our results, when I used the SGD classifier first, we started off with an accuracy of 90%, which means that in about 90% of the images that it guessed, it guessed the correct number around 90% of the times. Then, as we slowly tried out different algorithms, the accuracy slowly got better until when we used K and N, the accuracy rating got up to 97%. So overall, in the topic of AI, I learned about the basic concepts of AI. I delved a bit into machine learning, and I learned how to program with AI, such as dealing with data sets and modeling algorithms and knowing which one to use and how to find what the best one was. I also learned about training and testing data and how to split up the whole data set into different parts to help me when I was evaluating my results. And also practiced all these concepts by going into some projects. So technology and coding doesn't only have to be useful as a career. It's gonna just keep on being more relevant in the technologically advancing society. You may have heard that technology and robots might be taking over people's jobs in the future, and then with that becomes the need for better programs and software in place to work on those robots, since they will need better software and need to be upgraded for better efficiency and less mistakes made. And so later on, it's technology is only gonna improve more and more and become more relevant as it will start to integrate itself into many other aspects of our lives. And so coding, which is a fundamental part of technology, is just going to be more useful and have a lot more uses in the future. And it can also be integrated into many other fields. It doesn't just have to be in places such as being a software designer or data analysis. It can be used to create programs that can help in a variety of different fields, such as in the medical or maybe even the business side. So coding actually plays a very large role in society. You might not have realized it, but it's a very large role in our society and the places around us, and it's affecting a lot of the things that we think are commonplace and are simple. And coding is just like what it sounds like. It's like learning a whole new language. And what I've managed to cover in those 2 years is just the tip of the iceberg. And once you really start to get to the basics of it, you really start to take off, and it can be applied for a lot of different areas. And what coding is really all around us, and its major role will only continue to grow in the future.
So let's give them a round of applause. So time for questions. You guys have questions?